Good morning, everyone. Our project is about heart disease prediction. First, this code is the front-end code. Import pandas as PD. This import the pandas library and gives it the alias PD. Pandas is a powerful Python library used for data manipulation and analysis, especially useful when working with tabular data like spreadsheets or CSV files. Next is df equals pd.read underscore csv. pd.read underscore csv is a function in pandas that reads as a csv, common separated values, file and loads in a data frame. Content, which is a heart disease csv, it has a separate data set, which I'll show it in the later section, is a function in pandas that reads a csv. And also in this case, it looks like the code is running in the Google Colab, which files are typically stored under or content. Df is the variable that stores the loaded data. It stands for the data frame. That df.head, this line displays the first rows of 5 rows of the data frame. It is a quick way to preview the data set, check column names, data types, and sample values. Next, some key points about these columns, which is age, sex, CP is age. It is the age of the patient in years. It can be in sex, gender 1 equals male, 0 equals female. CP chest pain type 0 to 3. 0 it is a typical angina 1, atypical angina 2, non-typical angina 3, asymptotic. Trust BPS, resting blood pressure in mmHg, serum cholesterol in mg or dl, FBS, fasting blood sugar greater than 120 mg or dl, 1 equals true, 0 equals false, rest ECG, resting electrocardiograph results 0, 1, 2, Thalac, maximum heart rate achieved. Exact. Exercise induced angina 1 equals S, 0 equals no. Old peak. ST depression induced by exercise relative to reset. Slope. Slope of the peak exercise ST segment 0, 1, 2. CA. Number of major vessels, which is 0 to 3, colored by fluoroscopy. Thalassemia 1 equals normal, 2 equals fixed defect, 3 equals reversible defect. Target variable is 1 equals heart disease present, 0 equals not present. Some observations of this are all 5 columns shown have a target equals 1, indicating the presence of heart disease. Features like CP, THALS, slope, and rest CG are categorically but encoded as numbers. Some features are binary, sex, FBS, exact, others are continuous, age, call, Thalac, old peak, etc. Next will be explained by Kavya.
Hello everyone, myself Kavya. The code is from scikit-learn.preprocessing import standard scalar. This import the standard scalar class from scalar, which is used to standardize the future, a key processing step in machine learning. X is equal to df dot drop target comma axis is equal to 1. Y is equal to df target x future independent variable. Here you are dropping the target column because it's what you are trying to predict. Y labels dependent variable the target column which indicates whether the person has heart disease or not. Scalar is equal to standard scalar. You create a instance of standard scalar which will be used to normalize the future values. X underscore scalar is equal to scalar dot fit dot transform. This fits the scalar to the future data and then transform its. Standardization means the future will now have mean is equal to 0, standard deviation is equal to 1. This helps many ML algorithms perform better, especially those that rely on distance. Example KNN, SVM, logistic regression. The standardization is useful for put all features on the same scale, prevents future with a large scale from dominating the model, especially helping for a gradient-based algorithm. From scalar.model underscore selection, import train underscore test underscore split. This imports the train underscore test underscore split function from sklearn, which is used to split your dataset into training and testing subset. X underscore train, X underscore text, Y underscore train, Y underscore text is equal to text underscore split, X underscore scaled, Y underscore Y comma text underscore size is equal to 0.2, random underscore state is equal to 42. Part and description, X underscore scaled, that the futures are already standardized. Why the target labels 0 is equal to no or disease, 1 is equal to or disease. Test underscore size is equal to 0.2. 20% of the data will go into the test set. The 80% will be used for training. Random underscore state is equal to 42. Set a seed for the random number generator. So the split is reproducible. You will get the same split every time you run it. X underscore train comma X underscore test. Future data for training and testing. Y underscore train comma Y underscore text. Corresponding target labels for training and testing. From sklearn.linear underscore model import logistic regression. From sklearn.ensemble import random forest classifier. From sklearn.svm import svm. From sklearn.matrix import classification underscore report. Confusion underscore matrix comma accuracy underscore score. These line imports three machine learning algorithm, logistic regression and random forest support vector machine as well as evaluation tools like accuracy score, confusion matrix and classification reports. Models is equal to logistic regression, random forest classifier, SVM probability is equal to true. A dictionary called a models is created to store the three classifiers. Each key is the name of model and each value is an instance of the model. For name comma model in models dot items, model dot fit x underscore train comma y underscore train, y underscore pred is equal to model dot predicted x underscore test. This loop goes through each model, fit it to the training data and then makes prediction on the test data. Next will be explained by Prajwal.
Printf and name print accuracy underscore score of y underscore test comma y underscore pred print confusion underscore matrix y underscore test comma y underscore pred print of classification underscore report of y underscore test comma y underscore predict. For each model, the code prints the model's name, its accuracy score, how many prediction were correct, the confusion matrix to show how prediction were disturbing among classes, the confusion matrix to show how prediction were disturbing among classes, a classification report with precision, recall, and F1 scores for each classes. Logistic regression. The model achieved an accuracy of 85.25%. It correctly classified 25 out of 29 negative cases, no heart diseases, and 27 out of 32 positive cases, heart diseases. Precision and recall were fairly balanced with an F1 score of 0.85 for class 0 and 0.86 for class 1. Overall, the model performance well but slightly favor class 1. Random forest. The accuracy was slightly higher at 86.89%. It correctly predicted 24 out of 29 class 0 samples and 29 out of 32 class 1 samples. Precision was 0.95 for class 1, which recalls was higher for class 1 of 0.91. The model is quite balanced and handles both classes effectively with a better F1 score than logistic regression for class 1. Support vector machine SVM. SVM also achieved an accuracy of 86.89% matching random forest. It correctly classified 26 out of 29 negative cases and 27 out of 32 positive ones. Both classes have an F1 scores of 0.87 showing strong overall balance in performance. SVM had the highest recall for class 0 0.90, making it particularly good at identifying patients without heart diseases. Next will explained by Kumar.
From scikit-learn dot of matrix import ROC underscore of the curve AUC and the import of matplot of a lib dot python plot as PLT. This is important of the function which is needed to the calculate of ROC, a curve and the AUC. AUC is the area under the curve which has been for the plotting the slide and y underscore of the proba is equal to models of randoms forest dot of predict underscore of a proba and of y underscore of a test. This code has been useful for the positive classes of a one which has been random forest of the model, and this of the probabilities is interested to the hard classes of a label to build the ROC curves. And the FR FPR comma of TPR comma is equal to ROC underscore of a curve underscore of a test and y underscore of a proba. Here the false positive of the rate of a FPR and the true positive of the rate are the calculated the different threshold values are useful for the needed to plot of ROC curves. Next, ROC underscore of AUC is equal to AUC of F, FPR comma of TPR. This is the completely the area is under the curve. AUC is the minus the value of the between 0 and 1, and the higher of AUC is mean better than the model's performance. PLT dot figure and the PLT dot plot of FAR and TPR label is equal to AUC and the ROC of ROC underscore of AUC is 2F. This starts a new plot at the doors. It draws the ROC curve, labeling it of the AUC curve in the random two digital places, and the PLT dot of lot 0 comma 1 and 0 comma 1 and K is underscore of, and this is the adds to our diagonals dashes lines as a reference, and a PLT dot of X label false positive rate and the PLT dot Y label true positive and PLT dot of title ROC curve and PLT dot of legend and PLT dot of show. This shows us the label of a axis and add a title including the legend of the finally display the plot. Output, and this is the output. This is the output. The plot shows the all values the random forest and distinguish between the people with and the without heart diseases. Y-axis is the presence of a false positive rate, and the y-axis is presence of a true positive rate, and the blue lens is the ROC curve, which has been shows the model performance across all the classification threshold, and the dashes diagonals lines is on the basis which has line has been crossing the randomly could not follow the line of having a AUC of 0.5. Since the blue curve is far above the diagonals and the hugs the top left corner, the model performance are very well, and the AUC the area under curve is the 0.9 which has been excellently. It means the model has 93% chances of correctly diagnosis with between a patient or with the and with and without the diseases. And thank you.
This is the front end code where the any person can fill the patient's details. Now this code is written in the HTML GSS by using HTML and GSS. This is the front end code where we have used HTML, JSS, etc. Where now we can fill the details like age, as I can take like 40, male or female, chest pain, you can give any number, only 0 to 3. Let us take 2. Rating, blood pressure, anything. We have to fill the details in the front end. Cholesterol, true or false, fasting blood sugar, resting ECG, max heart rate achieved, exercise, where we have to predict. Now, next is about backend. Only front end has been completed. Then the backend, we have to do receiver user input, like we have to take a Jupyter notebooks and build a functional system where using a trained ML model to predict heart disease, which return the prediction yes or no, or probability of the heart disease prediction. In the backend, we have to train and save a model where train your best performing ML model, example random forest. Save the trained model and the standard scalar using Pickle. Building a backend API, Flask or Fast API. Create an endpoint, example predict or prediction that accepts user input, which is JSON format, applies a scalar to the input, uses the model to predict heart disease, returns the result as a JSON response. Connect front end, it is an optional, but we have to do it for further implementations. Build a simple web for or use a Streamlit to send data to the backend. Display the prediction using the result to the user. Deploy your backend to your platform like Heroku, Render, or AWS. These are the where we have to give the numbers or any predictions values. Next, in the backend, we can get the all the rate of the predictions and all. Backend we have not yet done. So this is our project. Thank you.